Well, welcome again, and today we're going to talk about the quotient rule. I want you to notice here that we need to take the derivative of this, and because it is a rational function, or because it's just simply a fraction with variables in both the numerator and denominator, we can't just use the power rule on it, nor well, I guess we can do transform it a little bit and possibly use the product rule. But we don't want to always have to do that. So what we have is we have something called the quotient rule, and it looks like this. If we want to take the derivative of something that has a function in both the numerator and the denominator, we follow this pattern, u prime v minus v prime u over v squared. Okay? So we're going to do the same thing. It's very similar to identification with the product rule, except this time we're dealing with the quotient rule. So we're going to say the numerator is always u and the denominator is always v. So when I take the derivative, all right, I say u prime first, and u prime is 1, so I don't have to write it, times v. All right, so v would be 2x minus, notice the minus sign here, the derivative of the bottom, or v, which is 2x, times the top, which is x, okay? Derivative of the bottom times the original top, and over the bottom squared. So we have x squared minus 4 squared, okay? And it's really just as simple as that. Now this can be simplified just a little bit. We get 2x minus 2x squared in the numerator over x squared minus 4. And that's, well, squared. And that's about all you can do. There's more you could expand, etc. But there's nothing else really we need to worry about here. All right, just a little simplification in the numerator and you're good to go. All right, so that's one particular example. Let's take a look at another. I'm going to bring this to the next page with us and store it next to us so we have that as a reminder again of the quotient rule. Here we go. We're going to take the derivative of this, and once again I like to just before I get started identify u and v. All right, and if you want to, you could go ahead and find what u prime and v prime is before we put it into the rule. But for us, I'm just going to go ahead and go straight into it. All right, u prime is first. That's the derivative of the numerator. So that's 2x plus 6 in parentheses, all right, times the denominator, which is the square root of x plus 1, minus, okay, going to have a big numerator here, the derivative of the bottom, which you remember is 1/2 x plus 1 to the negative 1/2. Remember, that's how we deal with that radical, times the top, which is x squared plus 6x plus 1, over the bottom squared. And the bottom squared, because it's a square root and we're squaring it, the radical goes away and we just have x plus 1. Now, we don't have to worry about simplifying the top here. It's possible, but it's a fairly complex process, so we're not going to worry about it. But let's review this again. Remember, this is u prime, this is v, this is v prime, and this is u. And that's where all these pieces come from. The derivative of u, times v, u prime v, minus the derivative of the bottom times the top there. Okay? One more quick example, and we'll call it here. Once again, I'm going to say this is u and v, and we're going to go through the process again. So dy dx is equal to u prime, which is 3x squared minus 12x. Be sure to put that in parentheses because that represents the entirety of u prime, that whole quantity, times the bottom, or the v, minus, okay, big minus sign there, the derivative of the bottom, parentheses again, 24x plus 3 times the original numerator, like so. Of course, over the bottom squared. Do not forget to put that bottom squared in. And there you have your answer. Okay? And that is the product, that is the quotient rule. And we'll continue practicing these. Thank you.